Hi there, we're going to be doing some adding and subtracting of rational expressions today. This is pretty much adding and subtracting of fractions. You need to have a common denominator in order to do that. So let's start off with something like this. 2x over x plus 1 plus 2 over x plus 1. Okay, looking at that, we do have common denominators, so we are allowed to add or subtract the numerator. So really your breakdown would then be this: 2x plus 2 over your common denominator of x plus 1. Then you always look to factor this, so I can pull a 2 out of the top, leaving me with x plus 1, and then it is over x plus 1. In this instance, you are allowed to cancel the entire x plus 1's, leaving you with a value of 2. Now you also need to be aware of excluded values. Excluded values, those are values that make your original problem, your original rational expressions in that problem, undefined. So the way that something becomes undefined is it has a denominator of 0. That is undefined. So what values would give these denominators or make these denominators 0? Well, one easy way of figuring that out would be to do the zero product property, or to set each one of these denominators to 0. This component, x plus 1 equals 0. That would be the same thing. If you solve this, x equals negative 1. So if you have a value of negative 1 in this original problem, you can't do it. It's undefined. So here, part of your answer, x cannot be negative 1. If x were negative 1, you would have undefined values. You could not proceed with this problem. So don't forget those excluded values, please. Okay, now I also want to talk a little bit about this canceling. I've seen in many instances something similar to this. Let's say you have 10x plus 4 over 10x. I have seen many an algebra student want to cancel the 10x here. That is just not allowed. It is held together with addition, and if it is held together with subtraction, you're not allowed to break those up. So the only thing that you could do here would be to factor a 2 out of the top, leaving you with 5x plus 2 over 10x. Now you're able to break up this multiplication problem and this multiplication problem to cancel the 2 and the 10. So you would be left with 5x plus 2 over, well, 2 and 10 reduces to 1 over 5, and don't forget your x, and you're done. You cannot cancel that. So just stop right there. The way I like to think about it is with a fraction similar to, let's say, 9/7. Okay, if I were to give you that fraction and ask you to reduce it, you would say that is done. You cannot reduce that thing any further. And I agree with you. But I can represent this fraction in a slightly different manner. Let's say it is 3 plus 4 on top, and then 3 plus 6 on the bottom. Okay, just because you have those two 3's there doesn't mean you can cancel them. If you were able to cancel that, we would then be led to believe that, hey, this whole fraction, with those 3's gone, would be 4/6, which reduces to 2/3, and you know that 7/9 is not 2/3. You are not able to break up that addition or subtraction to cancel, so don't even try that there. That's just a little side note for you. Let's keep moving here. Let's say 3x plus 4 over x minus 2 minus x minus 1 over x minus 2. One of the things you always want to do is look for these excluded values from your original problem. When your denominators are in factored form, that's when you should really apply that approach here. So if I were to take this denominator and make it equal to 0, I'm going to find out what value would make that denominator 0. X equals 2. So that is my excluded value. X cannot equal 2 in this problem, so we will put that into the answer. When x equals 2, it becomes undefined. Therefore, x cannot equal 2 as an excluded value. Well, we have common denominators here, so now you are able and allowed to add or subtract your numerators. 3x plus 4 minus the entire x minus 1 all over a common denominator of x minus 2. Don't forget to distribute that negative to everything that is left up there. So then we would end up with 3x plus 4 minus x plus 1 over x minus 2. Combine everything in this numerator. 2x plus 5 over x minus 2. Nothing there cancels, so you are done. Don't forget your excluded value. X cannot equal 2. Let's keep on moving forward here. Let's look at a plus 1 over a plus a minus 3 over 3a. Okay, so looking at this right here, you should start thinking about your excluded values. What values would give you denominators of 0? Well, 0 would make that one 0. And if this was 0, 3 times 0 is 0. So excluded values, a can't be 0. If a were 0, you're undefined. So that will be part of our answer. Now looking at this, we do not have a common denominator. A, 3a, so this fraction would need to be multiplied by 1. But when I say 1, I'm multiplying by 1 in the form of 3 over 3. You can multiply any fraction by 1, but this will give our denominator now the commonality and make it 3a, just as that one is 3a. So I'm going to have to also distribute this. Be aware, 3a plus 3 plus a minus 3 all over my common denominator now of 3a. Then I can combine terms up top, giving me, let's see, 4a, plus and minus cancels over 3a. Well, now looking at this, this is a multiplication problem. It is 4 times a and 3 times a. You can break up that multiplication and you can cancel those a's, leaving you with 4/3. So 4/3 is the simplified version. Don't forget, though, that a cannot equal 0. If a were to be 0, it would be undefined. That is part of our answer. That is an excluded value. We'll do one more here. That should work. 5a over a squared plus 3a minus 4 minus a minus 1 over a squared minus 1. So looking at that, we do not have a common denominator here. Okay, interesting. And looking at these denominators, I don't really know which values are going to make them 0, so one of the first things you want to do is you want to do some factoring. 5a, okay, the factors of 4 that give me 3. 4 and 1, ignore positives, and 1 negative. That indeed is my factoring. You can check it if you will. A minus 1, factor this, difference of squares, so a plus 1, a minus 1. All right, there we go. Now I'm looking at these denominators, and the zero product property will apply very nicely here. Hey, I can take this factor, a plus 4, set it to 0, a minus 1, set it to 0, a plus 1, set it to 0, a minus 1, set it to 0. I already have that one, so really I don't need to do that twice. I solve each one of these. A equals negative 4, a equals 1. I knew I was going to do that, changed it to an x, and a equals negative 1 right there. Those are your excluded values for your answer. A cannot be negative 4, a cannot be equal to 1, a cannot be equal to negative 1, so we're going to need to get that into our answer. Now looking right back here, one step up, you don't have a common denominator. A plus 4, a minus 1, a plus 1, a minus 1. So this one right here, this denominator is missing the a plus 1 component. So I will multiply top and bottom by a plus 1, which is really essentially multiplying it by 1. This denominator right here is missing the a plus 4. So it gets in top and bottom in the form of 1. A plus 4 over a plus 4 is 1. So now it is some distributing here. 5a times a, 5a squared, 5a times 1, positive 5a. Minus all of this. Okay, so now this is a times a squared, 4a, negative a, so that would be a positive 3a, and then a negative 4. Don't forget though, it is subtraction, so this whole thing now is being subtracted. All I did was multiply those two together. This negative will apply to everything in there. This fraction now has my common denominator. Of all that. So does this fraction. There you go. So we are now allowed to add or subtract the numerators. Okay, we're going to have to distribute this. So my first fraction, 5a squared plus 5a minus a squared minus 3a plus 4. And this is all over my common denominator now. A plus 1, a minus 1, a plus 4. We just keep kind of breaking this thing down, combine like terms. 5a negative a squared gives me 4a squared. 5a and negative 3a would be a positive 2a, and then I have a positive 4 all over my common denominator. Now we're going to look to factor this once everything is combined and see if we can cancel anything up top with anything on the bottom. So I will factor a 2 out of the top, leaving me with 2a squared plus a plus 2 all over. Now looking at this does not factor any further. So we are now essentially done. You would check to see if this factors and any one of those factors cancels down here. Not the case. A cannot be negative 4, 1, or negative 1, your excluded values from right up here. There you go. See you later.